So my name is Bruno da Silva Lopes, and today I'll talk a bit about exotic exotic particles in high energy physics. So before talking about those exotic particles, I'll give a short introduction to quarks and the standard model. So one property of quarks is and a property of QCD, quantum chromodynamics, the theory of the strong interactions, is the quark confinement. So the commonly observed matter that we observe day to day is made of protons and neutrons, but those particles are composed of confined quarks. So for example, a proton has two up quarks and a down quark. And color confinement requires that the free particles that we find in nature, they must be color neutral. So in this example, the proton is a baryon, so it must have all the three colors, red, blue, green. But we also have another type of particle, which is the meson, and it's composed by a quark and antiquark pair. So it must have a color and the respective anticolor. So studying the symmetries and conserved properties, the reactions and decays of those particles, we have a well-accepted theory of the elementary particles, which is called the Standard Model. So we have the fermions, which are divided in quarks and leptons, and the bosons, which mediate the interactions. So we have 6 types of quarks divided in 3 families. We have the up and down, the light quarks, the charm and strange, and the heaviest quarks, which are the top and bottom. So if you can see, the up quark, for example, has a mass of 2 mega electron volts, and the top quark has a mass of 170 giga electron volts. So it's much heavier. And for that reason, the up and down quarks were discovered first in the later half of the 1960s. I don't have a precise date because it took some time to be fully understood, while the top quark was only discovered in the 1995 at CDF, the collider detector at Fermi level. So, and that's because its high mass requires the accelerators to reach much higher energies. So we know those quarks can combine to form mesons, a pair of two quarks, and baryons, composed of three quarks. So are there any other forms that those particles can combine to form matter? And the answer is yes. Those are called the exotic particles. So one example are the Tetra quarks, and those are particles composed by 4 quarks, and they were theorized long before the first observation. The first observations were made in the 2000s, but we were not sure. The evidence was not conclusive enough. So the first conclusive evidence of the detection of a tetraquark was made in 2014 as the LHCb collaboration. The particle that was observed was the Z tetraquark. It has a mass of 4,430 mega electron volts, and it's composed by a charm, anti-charm, D, and anti-U quark. So observe that it's made of a charm and anti-charm pair, which we'll come back to later. So this is below you have the headline of the paper that was published. And there's another type of exotic particles, and those are called the pentaquarks. So similar to tetraquarks, pentaquarks are a composite particle now made of 5 quarks, and it was also predicted, but it was much more difficult to detect in experiment. Um, so I didn't put the year, sorry. It was in 2015 that the LHCb collaboration announced that a new type of particle containing 5 quarks was first observed. It was the PC 4450 with positive charge, and it has a composition charm, anti-charm, 2 U quarks, and a D quark. So below you also have the headline of the article. Now there are still some questions about how those particles are made, uh, what's their structure. So one possible example, those are confined in the bag of quarks. So the picture above, you have a bag where all those quarks that make up the pentaquark are confined together. But there's also another possible picture, which is the molecular pentaquark, and it will be, of course, like the name, very much like a molecular structure, where you have a regular baryon and a regular meson uh, very close together. So the recently, in the last year, July 2029, there was a new tetraquark announced, discovered at the Large Hadron Collider, and it has a mass of 3,870 mega electron volts, and it's composed by two charm quarks, an anti-U quark, and an anti-D quark. And this makes it the only charmed tetraquark we have found so far. Charmed means you have a property called charm, which is the difference in number of the charm quarks and antiquarks. So since this particle has two charm quarks, it's said to be charmed. And it was the first tetraquark with this property we have observed. The TCC plus is also okay. It's also interesting for some more reasons. It is believed that it, it doesn't follow this molecular quark structure. It would be two mesons instead of a baryon and a meson. It is believed to be confined in a bag of quarks. So that I have prepared. And thank you for your attention.